What if the universe had a secret backdoor, a hidden tunnel that could take you from one side of the cosmos to the other in the blink of an eye? Wormholes, those mysterious theoretical passages through space-time, have long captured the imagination of scientists and dreamers alike. They're not just the stuff of science fiction. They're a tantalizing possibility that challenges everything we know about space, time, and the limits of exploration. Today, we're diving into 30 theories about wormholes that might just be true, ideas that could fundamentally reshape how we understand the universe. From the scientific foundations to the wildest speculative wonders, this journey will take you through mind-bending concepts that could change the way you see the cosmos. Ready to explore one of space's greatest mysteries? Let's begin. One of the most fascinating ideas in theoretical physics began with two names you've probably heard before: Albert Einstein and Nathan Rosen. Back in the 1930s, while working on the equations of general relativity, they stumbled upon something extraordinary, a theoretical shortcut through the fabric of spacetime. They called it an Einstein-Rosen Bridge, a concept that would later become the foundation of what we now know as wormholes. At its core, this bridge is a solution to Einstein's equations, suggesting that spacetime can bend and stretch in ways that create a tunnel-like connection between two distant points. Think of it like a cosmic shortcut, where instead of traveling the full distance across the universe, you could step into one end of a wormhole and emerge light years away in an instant. Mathematically, these bridges are valid solutions, but they come with a catch. Early models suggested they'd be incredibly unstable, collapsing almost instantly under their own gravitational forces. So while Einstein and Rosen's work laid the groundwork for wormhole theory, it also left physicists with a tantalizing puzzle. Could these bridges ever become stable or even traversable? That question would spark decades of exploration, leading to some of the most imaginative theories in science. What if traveling across the universe could be as simple as stepping through a doorway? Traversable wormholes offer exactly that kind of promise, a shortcut through the fabric of space and time, connecting distant points in an instant. Think of it like folding a piece of paper so that two far apart dots touch, then poking a hole through them. That's essentially how a wormhole could work, bypassing the need for long, tedious journeys through space. These theoretical tunnels have captured the imagination of scientists and storytellers alike, offering a tantalizing glimpse into the future of interstellar travel. But here's the catch: for a wormhole to be traversable, it would need to stay open long enough and be stable enough for something or someone to pass through. This is where exotic matter comes into play. Unlike the ordinary matter we're familiar with, exotic matter has unique properties, including negative energy or mass. It's this bizarre substance that could theoretically counteract the immense gravitational forces that would otherwise collapse a wormhole. Without it, traversing a wormhole would be impossible, as the tunnel would snap shut faster than you could enter it. Physicists like Kip Thorne have played a pivotal role in bringing the concept of traversable wormholes into the spotlight. Thorne's work not only advanced the scientific understanding of these cosmic shortcuts, but also inspired their portrayal in popular culture, most notably in the movie Interstellar. His calculations showed that, under the right conditions, wormholes could be stable and navigable, at least in theory. While we're still far from building one, the very idea continues to fuel our dreams of exploring the cosmos in ways that were once thought impossible. So, what does it take to create a wormhole that's truly traversable? The answer lies in the strange and elusive nature of exotic matter, a topic we're about to dive into next. This mysterious substance might just hold the key to unlocking the universe's greatest shortcuts, and it's even stranger than you might think. So, what exactly holds a wormhole open? The answer might lie in something called exotic matter. Unlike the ordinary matter we're familiar with, exotic matter is a hypothetical substance with a negative energy density. Think of it as the opposite of what we see in everyday objects. While normal matter has positive mass and energy, exotic matter could theoretically push space and time in ways that defy our usual understanding of physics. This unique property could be the key to stabilizing wormholes, counteracting their natural tendency to collapse under their own gravitational forces. But here's the catch: exotic matter doesn't exist in nature as far as we know, or at least we haven't discovered it yet. Scientists are working hard to detect or even create this elusive substance, even in the tiniest amounts. Some experiments in quantum physics suggest that certain phenomena, like the Casimir effect, might mimic the properties of exotic matter on a very small scale. While these findings are promising, they're still a long way from the vast quantities needed to stabilize a wormhole. Still, the pursuit of exotic matter opens up fascinating possibilities, not just for wormholes but for our understanding of the universe itself. Now, if we could harness exotic matter and stabilize a wormhole, what could we do with it? It turns out that wormholes might not just be shortcuts through space, they could also function as time machines. Imagine stepping through a wormhole and emerging in the past or future. This idea might sound like science fiction, but it's rooted in serious theoretical physics, and that's exactly where we're headed next. What if the key to time travel has been hiding in the cosmos all along, not in the form of a sleek machine, but as a cosmic shortcut through the fabric of space-time? Wormholes, those mysterious tunnels through the universe, might not just connect distant places in space, but could also bridge different points in time. Imagine stepping into a wormhole and emerging in a different era, past or future. The idea sounds like science fiction, but it's rooted in the equations of Einstein's theory of general relativity. Here's how it could work. Wormholes, theoretically, could link regions of spacetime with different rates of time flow. For example, if one end of a wormhole were near a massive object like a black hole, where time moves slower due to intense gravity, and the other end were in a region with weaker gravity, the two ends would experience time at different speeds. This difference creates what's known as a time machine through space-time. You could enter one end and exit the other, effectively traveling through time. This concept ties into the famous twin paradox, a thought experiment in which one twin travels at near light speed while the other remains on Earth. When the traveling twin returns, they find their sibling has aged more. A wormhole could act as a bridge for a similar effect, allowing one end to experience time differently than the other. Entering one side could mean stepping into the future, or even the past, depending on how spacetime is warped. But here's the catch: for wormholes to function as time machines, they'd need to be stable and traversable. Most theoretical wormholes are incredibly unstable, collapsing almost instantly under their own gravitational pull. Some scientists speculate that exotic matter, material with negative energy, might be needed to keep them open. Yet, even if such matter exists, the challenges of manipulating it are immense. So, could wormholes naturally exist in the universe, waiting to be discovered? Or are they purely a theoretical construct, forever confined to equations and thought experiments? The answers might lie in the deeper mysteries of spacetime itself, and that's where we're headed next. What if the universe has already provided us with cosmic shortcuts, hiding them in plain sight? This leads us to the fascinating idea of natural wormhole structures that might have formed during the extreme conditions of the early universe or through the violent collisions of black holes. Unlike the wormholes we often imagine as artificially created tunnels, these natural versions could be scattered across the cosmos, waiting to be discovered. Think about the immense forces at play in the moments after the Big Bang or during the merger of two black holes. Such events could warp spacetime so intensely that they create stable passages, wormholes connecting distant parts of the universe. These natural wormholes might not look like the sci-fi versions we're used to. In fact, they could be so similar to black holes that we've been mistaking them for one another all along. Both black holes and wormholes share the characteristic of intense gravity, but unlike black holes which trap everything forever, wormholes could offer a way through. So how do we tell them apart? Scientists are turning to gravitational waves, ripples in space-time caused by massive cosmic events, for answers. Detecting these waves could reveal subtle differences between black holes and wormholes. For instance, the way space-time behaves near a wormhole might leave a unique signature in the gravitational wave data, offering clues to their existence. As we dig deeper into the mysteries of natural wormholes, it's worth noting how closely they're tied to black holes, both in theory and in the way we might observe them. This connection brings us to the next piece of the puzzle, the intricate relationship between wormholes and black holes, and how understanding one might help us unlock the secrets of the other. One of the most intriguing connections in the cosmos is the relationship between wormholes and black holes. At first glance, they seem like entirely different phenomena. Black holes are known for their immense gravitational pull, swallowing everything that comes too close, while wormholes are often portrayed as cosmic shortcuts, bridging distant points in space and time. But mathematically, they share striking similarities. Both are solutions to Einstein's equations of general relativity, and both involve extreme distortions of spacetime. In fact, some theories suggest that wormholes could be hidden within black holes, creating pathways to other regions of the universe. However, their functional roles couldn't be more different. While black holes are cosmic vacuum cleaners trapping matter and light within their event horizons, wormholes are theorized to act as tunnels if they exist. Enter the concept of a white hole, the hypothetical exit point of a wormhole. Unlike a black hole, a white hole would theoretically repel matter and light, spewing it out into another region of space or even another universe. It's an idea that captures the imagination, but it's important to note that white holes remain purely theoretical. No evidence of their existence has ever been observed, and they're often considered the opposite of black holes in thought experiments rather than confirmed cosmic objects. So, why does this relationship matter? Understanding the interplay between wormholes and black holes could unlock profound insights into the nature of spacetime itself. It's a reminder that the universe is full of mysteries waiting to be unraveled. And speaking of mysteries, the next frontier in this exploration takes us into the realm of quantum mechanics, where the rules of the very small might just hold the key to understanding how wormholes could function. If wormholes exist on a cosmic scale, could they also be hiding in the quantum realm? This is the mind-bending question posed by the ER=EPR conjecture, a theory that bridges the worlds of general relativity and quantum mechanics. The idea suggests that wormholes and quantum entanglement might be two sides of the same coin. Imagine two particles entangled across vast distances, instantly influencing each other's state. Now picture a microscopic wormhole connecting them, a tiny tunnel through spacetime that explains this strange phenomenon. This is the essence of ER=EPR, where the letters stand for Einstein-Rosen Bridges, another term for wormholes, and Einstein-Podolsky-Rosen, the trio behind the concept of quantum entanglement. This theory isn't just speculative, it's a potential key to unifying two of physics' most fundamental yet seemingly incompatible frameworks. General relativity describes the universe on large scales, while quantum mechanics governs the behavior of particles at the smallest levels. The ER=EPR conjecture proposes that wormholes at the quantum level could act as the glue holding these theories together. It's a tantalizing idea that opens the door to understanding how the universe operates at every scale, from the tiniest particles to the vast expanses of space. But what if wormholes aren't just confined to the quantum world or the four dimensions we're familiar with? Could they stretch even further into realms beyond our comprehension? That's where the concept of higher dimensional wormholes comes into play, a thought that takes us into even more uncharted territory. What if the key to traversing wormholes lies beyond the dimensions we can perceive? While we live in a three-dimensional world, modern physics suggests that our universe might actually exist in higher dimensions somewhere between 8, 10, or even more. This idea isn't just science fiction, it's a cornerstone of string theory, one of the most promising frameworks in physics today. According to this theory, wormholes could be far more stable and feasible if they were anchored in these extra dimensions. In our three-dimensional reality, wormholes are fragile and prone to collapse, but in a higher dimensional space, they might remain open and navigable. Think of it like this: if our universe is a flat sheet of paper, higher dimensions would be like folding that paper in ways we can't fully comprehend, creating shortcuts that bypass the limits of our 3D world. The implications are staggering. If wormholes do exist in higher dimensions, they could act as cosmic gateways, allowing us to travel vast distances, or even through time in ways that seem impossible in our current understanding of space. But here's the kicker: these extra dimensions might be curled up or hidden, meaning they're inaccessible to us right now. Scientists are still searching for evidence of their existence, but if they're real, they could revolutionize our understanding of the cosmos. This brings us to an even more extraordinary idea. Could these higher dimensional wormholes also serve as portals to parallel universes? That's a question we'll explore next as we dive into the mind-bending possibilities of multiverse theory. What if the universe we see is just one thread in an endless tapestry of realities? This is where wormholes take us into the realm of the multiverse, a concept that suggests our universe might be just one of countless others. According to multiverse theories, wormholes could serve as bridges between these parallel worlds, offering a way to traverse the cosmic divide. Imagine stepping through a tunnel in space-time and emerging in a reality where the laws of physics are subtly, or even drastically different. The idea isn't just science fiction. It's a serious possibility explored by physicists trying to make sense of some of the universe's greatest mysteries. One of the biggest puzzles is dark energy, the mysterious force driving the accelerated expansion of our universe. Could it be that dark energy is somehow linked to the influence of other universes bleeding through wormholes? Another enigma is the fine-tuning of physical constants. Why are the fundamental forces and particles so perfectly calibrated to allow for life as we know it? Some scientists suggest that our universe might be just one of many, each with its own unique set of physical laws. Wormholes could be the key to understanding why our reality seems so finely balanced, as they might allow for interactions between these universes. This idea opens up a tantalizing possibility. What if the multiverse isn't just a collection of isolated realities, but a network of interconnected worlds with wormholes acting as the cosmic highways? While this remains speculative, it's a fascinating lens through which to view the universe's deepest questions. And speaking of cosmic mysteries, let's shift our gaze to another profound phenomenon: the role wormholes might have played in the rapid expansion of the early universe, known as cosmic inflation. Could these tunnels in space-time have shaped the very fabric of reality as we know it? One of the most intriguing questions in cosmology is how the universe expanded so rapidly in its earliest moments, a phenomenon known as cosmic inflation. But what if wormholes were part of that story? Some scientists propose that these mysterious tunnels in space-time could have acted as seeds for the dramatic expansion we see in the universe today. Picture this: tiny wormholes formed in the chaotic aftermath of the Big Bang might have served as focal points for the intense energy driving inflation. These structures could have influenced how matter and energy were distributed, shaping the large-scale web of galaxies and cosmic voids we observe now. The idea isn't just speculative, it's rooted in the physics of space-time itself. Wormholes, with their ability to connect distant regions, might have created irregularities in the fabric of the early universe. These irregularities could have acted like cosmic scaffolding, guiding the flow of energy and matter during inflation. Think of it as a blueprint for the universe's structure, where wormholes provided the framework for everything that followed. This theory doesn't just offer a new perspective on cosmic inflation. It also suggests that wormholes might have left an imprint on the universe that we can still detect today. But the story doesn't end there. As we continue to explore the mysteries of wormholes, another puzzling question arises. Could these structures be linked to dark matter? The invisible substance that makes up most of the universe's mass remains one of the greatest enigmas in science, and wormholes might hold the key to understanding it. What if the mysterious dark matter that makes up so much of our universe isn't made of particles at all, but something far stranger: wormholes? This speculative theory suggests that these cosmic shortcuts might be hiding in plain sight, woven into the very fabric of space-time. Picture this: instead of particles, vast networks of wormholes could be the invisible scaffolding holding galaxies together, explaining why stars orbit faster than expected at their edges. This idea isn't just science fiction, it's a serious proposal that challenges our understanding of the cosmos. Galactic rotation curves have long puzzled scientists. Observations show that stars on the outskirts of galaxies move at speeds that don't align with the visible matter we can see. Dark matter was introduced as a solution, but its true nature remains one of the greatest mysteries in physics. If wormholes were scattered throughout galaxies, they could provide the missing gravitational pull without the need for exotic particles. These hidden structures would act like cosmic anchors, subtly shaping the motion of stars and gas. The implications don't stop there. If wormholes are part of the dark matter puzzle, they could also influence other cosmic phenomena, from the way galaxies cluster together to the behavior of light on the largest scales. This theory opens up a new way of thinking about the universe, where wormholes aren't just curiosities but fundamental components of reality. Moving from the speculative to the mind-bending, let's explore how wormholes might connect to the holographic principle, a concept that suggests our three-dimensional reality could be a projection of a two-dimensional surface. This idea takes us even deeper into the strange and fascinating world of theoretical physics. Imagine the universe as a giant hologram, where every piece of information about its contents is encoded on its outer surface. This is the essence of the holographic principle, a mind-bending idea that suggests the entirety of our three-dimensional reality might be projected from a two-dimensional boundary. Now here's where wormholes come into play. If the universe's information is stored on its edges, how does it flow and interact across vast distances? Wormholes could be the answer, acting as cosmic bridges that connect these distant points in space-time, allowing information to travel seamlessly from one location to another. This isn't just science fiction, it's a concept grounded in the cutting-edge theories of quantum mechanics and general relativity. Think of it like this. If the universe is a vast library, the holographic principle suggests that all the books are stored on the walls. Wormholes, then, could be the secret passageways that let you access any book instantly, no matter how far away it is. This idea isn't just fascinating, it has profound implications for our understanding of reality. Could wormholes be the key to unlocking the deeper mysteries of how information is stored and transmitted across the cosmos? It's a question that brings us to the edge of our current scientific knowledge. But how does this tie into the bigger picture? If wormholes truly act as information bridges, they might also hold the key to understanding the fundamental nature of spacetime itself. And that brings us to the next piece of the puzzle. The role of wormholes in the realm of quantum gravity, where the rules of the incredibly small meet the laws governing the vast expanse of the universe. How do these enigmatic structures behave when we merge quantum mechanics with gravity? The answers might just reshape everything we thought we knew about the cosmos. Quantum gravity sits at the frontier of modern physics, attempting to bridge the gap between two of the most profound yet seemingly incompatible theories, general relativity and quantum mechanics. General relativity explains the universe on a massive scale, describing the behavior of gravity and the fabric of spacetime itself. Quantum mechanics, on the other hand, governs the smallest particles and forces in the universe, operating under a completely different set of rules. For decades, physicists have sought a unified theory that can reconcile these two frameworks, and wormholes might just hold a piece of the puzzle. One of the most intriguing ideas in this quest involves the holographic principle, championed by physicists like Leonard Susskind and Juan Maldaisner. This principle suggests that all the information in a volume of space can be thought of as encoded on a boundary to that space, much like a hologram. Maldaisner's work on the AD/CFT correspondence, a groundbreaking theory linking a type of spacetime to a quantum field theory, has opened up new ways to explore how wormholes could connect these seemingly disparate worlds. In this framework, wormholes might not just be cosmic shortcuts but also intricate networks of entanglement, weaving together quantum particles across vast distances. The connection between wormholes and quantum gravity raises fascinating possibilities. Could wormholes be a manifestation of quantum entanglement on a cosmic scale? Some theories suggest that entangled particles might be linked by microscopic wormholes, hinting at a deeper relationship between spacetime and quantum mechanics. This idea challenges our traditional understanding of space and time, painting a universe where the very fabric of reality is far more interconnected than we ever imagined. As we peel back the layers of this mystery, it's clear that wormholes aren't just science fiction, they're a key to unlocking some of the deepest questions in physics. And while we're still far from a complete theory of quantum gravity, the work of visionaries like Susskind and Maldaisner offers a tantalizing glimpse into a future where these extremes might finally unite. This leads us to another mind-bending possibility. Could wormholes also serve as cosmic recycling mechanisms, repurposing energy and matter in ways we're only beginning to understand? What if the universe itself had a way to recycle its energy, creating a continuous cycle of birth, death, and rebirth? This intriguing idea brings us to the concept of wormholes as cosmic recyclers. Imagine a universe where black holes don't just consume matter and energy but send it elsewhere through wormholes, redistributing it in a way that could spark new beginnings. This theory suggests that wormholes might play a crucial role in the grander cosmic cycle, potentially leading to what scientists call a cyclical universe. The Big Bounce theory, for instance, proposes that instead of a one-time Big Bang, the universe undergoes endless cycles of expansion and contraction. Wormholes could be the mechanism that allows matter and energy to survive the collapse of one universe and seed the birth of the next. It's like a cosmic conveyor belt where everything that seems lost in a black hole might reappear billions of years later, fueling the next iteration of existence. Eternal inflation adds another layer to this idea. In this model, our universe is just one bubble in an endless sea of expanding space-time. Wormholes could act as bridges between these bubbles, allowing energy and matter to flow from one universe to another. This wouldn't just recycle the building blocks of the cosmos, it could create an interconnected multiverse where every end is also a beginning. This theory of wormholes as cosmic recyclers challenges our understanding of the universe's lifespan. Instead of a linear narrative of creation and heat-death, it paints a picture of an eternal, self-sustaining system. And while this idea is still speculative, it opens up fascinating possibilities about the nature of existence itself. But what if wormholes don't just recycle matter and energy across space? What if they also twist and loop time itself? This leads us to the next frontier, wormholes and their potential to create time loops where the past, present, and future might intertwine in ways that defy our understanding. What if passing through a wormhole didn't just take you to a different place, but a different time, or even trap you in an endless loop? This is where the concept of closed timelike curves comes into play. These are theoretical pathways that could allow an object or even a person to travel back in time and encounter their past self. At first glance, it sounds like the stuff of science fiction, But when you combine wormholes with the equations of general relativity, the idea starts to feel eerily plausible. One of the most famous thought experiments tied to this is the grandfather paradox. Imagine traveling back in time through a wormhole and accidentally preventing your own grandfather from meeting your grandmother. If that happens, you would never be born. But if you were never born, how did you go back in time to interfere in the first place? It's a mind-bending contradiction that challenges our understanding of cause and effect. Physicists have proposed various solutions to this paradox, including the idea of parallel universes. In this scenario, your actions in the past create an alternate timeline, preserving the original sequence of events in the universe you came from. But time loops aren't just about paradoxes, they also raise questions about free will and determinism. If the universe allows for closed time-like curves, does that mean everything is predestined? Or could there still be room for choice, even within a loop? These are the kinds of questions that keep physicists and philosophers up at night. While we don't have definitive answers, the exploration of these ideas pushes the boundaries of our understanding of time, space, and reality itself. As we untangle these mysteries, it's worth noting that the implications of wormholes extend far beyond time travel. In fact, their potential to manipulate space and time has sparked exciting developments in another cutting-edge field: quantum computing. What if the key to unlocking the ultimate supercomputer lies not in silicon chips, but in the fabric of space-time itself? Enter the mind-bending idea that wormholes could serve as cosmic information highways, revolutionizing the way we think about communication and computation. This theory suggests that wormholes, those hypothetical tunnels through space-time, might not just connect distant regions of the universe. They could also act as conduits for quantum information, potentially enabling faster-than-light data transfer or even quantum computing on an unimaginable scale. This idea builds on the fascinating relationship between wormholes and quantum entanglement, a cornerstone of quantum physics. In simple terms, entanglement allows particles to be linked in such a way that the state of one instantly influences the other, no matter how far apart they are. Some physicists have proposed that these entangled particles might be connected by microscopic wormholes, a concept known as the ER=EPR conjecture. It's a theory that blurs the line between the physics of the very large and the very small, suggesting that wormholes could be the hidden infrastructure of the quantum world. While this remains speculative, the implications are staggering. Imagine a future where we harness wormholes to create quantum networks, transmitting information instantaneously across the cosmos. Of course, this raises questions about the laws of physics. Could such a system bypass the speed of light? Could it even challenge our understanding of causality? These are the kinds of puzzles that keep physicists up at night, and they remind us that the universe is far stranger and more interconnected than we might have thought. But as we ponder these possibilities, another intriguing mystery awaits: the role of wormholes in the cosmic censorship hypothesis. What happens when these space-time shortcuts interact with the most extreme objects in the universe? What if the universe has its own way of keeping its deepest secrets hidden? This is the essence of the cosmic censorship hypothesis, a thought-provoking idea in theoretical physics. It suggests that singularities, those infinitely dense points where the laws of physics break down, are always concealed, shielded from the rest of the cosmos. But how might this work, and could wormholes have a role to play? Wormholes, often imagined as cosmic shortcuts, might also serve as cosmic veils. Picture them as tunnels not just through space, but as structures that wrap around singularities, hiding them from view. This could explain why we don't see these extreme phenomena tearing through the fabric of reality. Instead, they might be tucked away, safely isolated by the geometry of wormholes. It's a fascinating possibility that adds another layer to these already mysterious objects. This idea also ties into the broader question of how the universe maintains its stability. If singularities were exposed, their extreme nature could lead to unpredictable and potentially catastrophic effects. Wormholes in this scenario act as cosmic guardians, ensuring that the most volatile elements of the universe remain contained. As we continue this journey, let's explore another intriguing role wormholes might play, not just as veils or shortcuts, but as pivotal structures that help stabilize the cosmos itself. Wormholes might do more than just connect distant points in space. They could also play a crucial role in maintaining the balance of the universe itself. Think of them as cosmic stabilizers, acting almost like invisible anchors that prevent the fabric of space-time from collapsing or tearing apart under the immense pressures of cosmic forces. One of the biggest mysteries in science is dark energy, the mysterious force driving the universe's accelerated expansion. What if wormholes are nature's way of counteracting this expansion? Some theories suggest that these structures could help distribute energy more evenly across the universe, acting as a kind of cosmic regulator. They might even prevent the universe from expanding so rapidly that it eventually rips itself apart in a scenario known as the Big Rip. Another intriguing possibility is that wormholes could help balance the gravitational pull of massive objects like black holes or galaxy clusters. By creating shortcuts through space-time, they might mitigate the extreme gravitational forces that could otherwise disrupt the delicate equilibrium of the cosmos. This could explain why the universe has remained so remarkably stable over billions of years, despite the chaotic forces at play. As we consider the role of wormholes in maintaining cosmic balance, it's worth noting that their influence might extend to the quantum world as well. In fact, some scientists believe wormholes could be intricately linked to the strange and unpredictable nature of quantum foam, the bubbling fabric of space-time at the smallest scales. But that's a story for the next section, where we'll dive into the fascinating intersection of wormholes and quantum physics. Picture the universe at its most fundamental level, far smaller than atoms or even quarks. Here, in the realm of the unimaginably tiny, space-time isn't the smooth, continuous fabric we often imagine. Instead, it's more like a bubbling, frothing ocean, what physicists call quantum foam. This chaotic sea is made up of space-time fluctuations, constantly shifting and churning at scales so minute they defy comprehension. It's as if the very fabric of reality is alive, seething with energy and possibility. Within this quantum foam, something extraordinary can happen. Tiny wormholes, sometimes referred to as Einstein-Rosen Bridges, might spontaneously form. These aren't the massive cosmic tunnels we see in science fiction. Instead, they're fleeting, microscopic phenomena that appear and vanish in an instant, like bubbles popping on the surface of a boiling pot. While they're too small and short-lived to be detected directly, their existence hints at a deeper truth. Wormholes could be a natural byproduct of space-time's inherent instability at the quantum level. This raises a fascinating question. Could these tiny wormholes ever stabilize or grow larger? Some theories suggest that under the right conditions, perhaps with the influence of exotic matter or immense energy, they might. But for now, their existence remains a tantalizing possibility, a reminder that even the most familiar aspects of the universe, like space-time itself, hold secrets we're only beginning to uncover. And speaking of space-time's mysteries, let's shift our gaze to something even more mind-bending: the idea that wormholes could act as cosmic shortcuts, even for something as fast as light. What if these strange tunnels could bend the rules of the universe, allowing light to traverse distances in ways that defy our understanding of speed and time? One of the most mind-bending ideas about wormholes is their potential to allow light, or even information, to travel faster than the speed of light. From an outside observer's perspective, if a beam of light were to enter a wormhole, it could emerge on the other side almost instantaneously, seemingly breaking the cosmic speed limit. This doesn't mean light is actually traveling faster than light within the wormhole itself, but rather that the shortcut through space-time creates the illusion of faster-than-light travel. It's like taking a secret tunnel through a mountain instead of driving around it. It gets you there quicker, even if your speedometer stays the same. This concept could have profound implications for how we understand certain astronomical phenomena. For instance, some observations in deep space show objects that appear to be moving faster than light, a phenomenon known as superluminal motion. Could wormholes be at play here? While there's no direct evidence yet, the idea offers a tantalizing explanation for these cosmic puzzles. It also ties into the famous Einstein-Rosen paradox in quantum mechanics, where particles seemingly communicate instantly across vast distances. Could wormholes be the hidden bridges making this possible? As we ponder these possibilities, it's worth remembering that wormholes aren't just shortcuts for light. They might also be key players in the grand story of the universe's evolution. What role could they have played in shaping the cosmos as we know it? That's where we're headed next. Could wormholes be more than just theoretical shortcuts through space? What if they've actually shaped the very fabric of the universe? This idea takes us into the realm of cosmic evolution, where wormholes might have played a pivotal role in sculpting the cosmos as we know it. Picture the early universe, a chaotic and dense soup of energy and matter. Some theories suggest that wormholes, if they exist, could have acted as cosmic architects, guiding the formation of galaxies, stars, and even planets. Think of them as invisible threads weaving through the universe, creating pathways for matter to flow and gather. Without these hypothetical structures, the distribution of galaxies might look entirely different. Wormholes could have influenced the large-scale structure of the cosmos, creating voids and filaments that define the cosmic web. In essence, they might have been the universe's way of organizing itself on a grand scale. But how would this work? Imagine a wormhole acting like a cosmic funnel, pulling in matter from one region and depositing it in another. Over billions of years, this process could have seeded the birth of galaxies, clustering stars and planets in specific areas. It's a tantalizing thought, wormholes not just as passageways, but as active participants in the story of the universe. This perspective opens up a whole new dimension to their potential role. Rather than being static features, wormholes could have been dynamic forces, shaping the cosmos over time. As we continue to explore this idea, it raises even more questions about their nature and function. Are they still shaping the universe today, or was their influence limited to the early stages of cosmic history? Now, let's shift our focus to another fascinating possibility: wormholes as cosmic messengers. If these structures exist, could they be transmitting information across vast distances in ways we're only beginning to understand? What if wormholes could do more than just transport matter across the universe? What if they could also carry information, acting as cosmic messengers between distant corners of space? This intriguing possibility has sparked a lot of speculation among scientists and science fiction writers alike. The idea revolves around the notion that wormholes could serve as bridges not just for physical travel, but for transmitting data, perhaps even enabling communication between civilizations separated by unimaginable distances. At the heart of this theory is the concept of quantum entanglement, a phenomenon where particles become linked in such a way that the state of one instantly influences the state of another, no matter how far apart they are. Some researchers suggest that wormholes could be the physical manifestation of these entangled connections, creating shortcuts that allow information to travel faster than light. This ties into the holographic principle, which proposes that all the information in a volume of space can be represented as data on its boundary, like a cosmic USB drive. If that's the case, wormholes might act as the cables that connect these boundaries, transmitting information across the universe in ways we're only beginning to understand. But what does this mean for the possibility of interstellar communication? If wormholes could carry information, it could open up entirely new avenues for civilizations to share knowledge, culture, and ideas across the stars. Imagine a future where we're not just exploring the cosmos, but actively talking to beings from other worlds, all thanks to these cosmic tunnels. Of course, this is all still in the realm of speculation, but it raises fascinating questions about the nature of the universe and our place within it. As we continue to explore these ideas, we're reminded that the universe is far stranger and more interconnected than we often assume. And speaking of interconnectedness, this leads us to another mind-bending concept: wormholes and their potential role in cosmic consciousness. But that's a story for the next part of our journey. What if wormholes aren't just bridges through space and time, but also connections between minds scattered across the cosmos? It's a mind-bending concept that takes us into the realm of cosmic consciousness. Imagine a universe where every conscious being, from humans to extraterrestrial civilizations, is linked through these cosmic tunnels. This idea ties into panpsychism, the philosophical theory that consciousness is a fundamental aspect of the universe, much like space or time. If true, wormholes could be the channels through which thoughts, emotions, and even collective awareness flow, creating something akin to a unified mind across the stars. Think of it as the ultimate network, where every node, every conscious entity contributes to a shared experience of the universe. This raises profound questions. Could wormholes allow us to tap into this cosmic consciousness? And what would it mean for our understanding of identity, individuality, and connection? Theories like these push the boundaries of science and philosophy, blending the physical with the metaphysical. As we ponder these possibilities, it's fascinating to consider how wormholes might play a role not just in connecting minds, but also in the larger cosmic cycle of creation and renewal. This leads us to the next intriguing idea: the role of wormholes in recycling the universe itself. What if the universe itself is engaged in an endless cycle of renewal, with wormholes acting as the unseen architects of this cosmic recycling? This intriguing theory suggests that wormholes could play a pivotal role in the redistribution of matter and energy across the cosmos, potentially creating a self-sustaining loop of existence. Imagine the remnants of collapsed stars, the debris of ancient galaxies, or even the energy left behind by supernova being funneled through these space-time tunnels, only to re-emerge somewhere else, ready to fuel the birth of new stars, planets, and even entire universes. This idea ties into broader cosmological concepts like the Big Bounce, which proposes that our universe could be part of an infinite cycle of expansion and contraction, rather than a one-time event born from the Big Bang. Wormholes in this scenario could serve as conduits that allow matter and energy to escape the collapse of one universe and seed the birth of the next. It's a compelling vision of cosmic recycling, where nothing is truly lost, just transformed and repurposed across the vast expanse of space-time. Eternal inflation, another related theory, suggests that our universe is just one of many bubbles in a multiverse, each expanding and evolving independently. Wormholes could act as bridges between these bubbles, transferring energy and matter in ways that keep the multiverse in a state of perpetual dynamism. This not only opens up fascinating possibilities for the structure of reality, but also hints at a deeper interconnectedness that binds the cosmos together. As we ponder these ideas, it's worth considering how they might reshape our understanding of existence itself. Could wormholes be the key to unlocking the mysteries of cosmic rebirth? And if so, what does that mean for the future of our universe or even our place within it? These questions lead us to an equally tantalizing topic: the relationship between wormholes and cosmic censorship, a concept that challenges our understanding of the fundamental laws governing the universe. But more on that in just a moment. Have you ever wondered if the universe has a way of keeping its most extreme secrets under wraps? This is where the cosmic censorship hypothesis comes into play. At its core, this idea suggests that nature abhors a naked singularity, a point of infinite density and zero volume that isn't hidden behind an event horizon. Essentially, the universe might have a built-in mechanism to prevent such singularities from being exposed, and wormholes could be key players in this cosmic cover-up. Think of a wormhole as a kind of veil, a natural barrier that shields these singularities from the rest of the universe. If a singularity were to exist without an event horizon, like the one at the center of a black hole, it would wreak havoc on the laws of physics as we know them. Wormholes might serve as a solution, creating pathways that redirect or conceal these anomalies, keeping the fabric of spacetime intact. This raises fascinating questions about the nature of black holes and whether they might be hiding more than we've ever imagined. The implications of this idea are profound. If wormholes do indeed act as cosmic veils, they could help us reconcile some of the most puzzling aspects of general relativity and quantum mechanics. For instance, they might offer a way to understand how information escapes a black hole, a problem that has stumped physicists for decades. Additionally, this concept challenges us to rethink the very structure of spacetime, suggesting that wormholes aren't just shortcuts through the cosmos. They might also be essential tools for maintaining its stability. As we peel back these layers of mystery, another intriguing possibility emerges. What if wormholes aren't just hiding singularities, but also playing a role in stabilizing the universe itself? This idea brings us to our next exploration, where we'll examine how wormholes might act as cosmic stabilizers, ensuring the balance and harmony of the cosmos on a grand scale. One of the most fascinating theories about wormholes suggests they could play a critical role in maintaining the universe's delicate balance. Imagine the cosmos as a vast, interconnected web, with wormholes acting as hidden threads that keep everything from unraveling. Some scientists propose that these mysterious structures might counteract the effects of dark energy, the force driving the universe's accelerated expansion. If dark energy continues to push galaxies apart at an increasing rate, wormholes could serve as cosmic stabilizers, redistributing energy and mass to prevent the universe from tearing apart. This theory opens up intriguing possibilities. For example, wormholes might act like cosmic shock absorbers, mitigating the extremes of universal forces. They could theoretically channel energy from overpopulated regions of spacetime to areas where it's needed most, creating a kind of equilibrium. Think of it as a cosmic seesaw, where wormholes ensure that no part of the universe becomes too dense or too empty. But how does this work on a practical level? One idea is that wormholes interact with the fabric of spacetime itself, smoothing out irregularities and preventing the buildup of destructive forces. This could help explain why the universe hasn't collapsed under its own weight or been ripped apart by dark energy. While this remains speculative, it highlights the potential for wormholes to be more than just shortcuts through space. They could be essential components of the universe's infrastructure. This leads us to another curious concept. Wormholes might exist at scales far smaller than we've ever imagined, woven into the very fabric of spacetime itself. Which brings us to the next intriguing idea: wormholes and quantum foam, where the rules of physics as we know them take a fascinating turn. The universe at its smallest scales is a chaotic, bubbling sea of activity, and this is where the concept of quantum foam comes into play. Picture spacetime not as a smooth, unbroken fabric, but as a frothy, turbulent ocean, constantly fluctuating at the tiniest levels. These fluctuations, occurring at the Planck scale, where distances are so minuscule they're almost impossible to comprehend, create a dynamic, ever-changing landscape. Within this quantum foam, it's theorized that wormholes could spontaneously form and vanish, appearing like fleeting bubbles in this cosmic froth. This idea suggests that the very fabric of spacetime isn't just a static backdrop but an active, seething entity. Wormholes in this context might emerge as natural byproducts of these fluctuations, offering temporary bridges between different points in spacetime. While these wormholes would likely be incredibly small and short-lived, their existence could revolutionize our understanding of the universe's structure. It challenges the notion that spacetime is uniform and instead reveals a more intricate, dynamic reality at the smallest scales. delving into quantum foam also opens up fascinating questions about the nature of reality itself. Could these fleeting wormholes hold the key to understanding how space-time operates at the quantum level? Some scientists propose that they might even play a role in the behavior of particles, influencing the very foundations of quantum mechanics. This interplay between wormholes and quantum foam hints at a deeper connection between the universe's largest structures and its tiniest components, bridging the gap between general relativity and quantum theory. As we consider the implications of quantum foam and its potential to spawn wormholes, it's worth noting how this idea connects to the broader cosmic picture. If light itself could traverse these microscopic wormholes, it might reveal entirely new pathways through the universe. This leads us to the next intriguing possibility: wormholes as cosmic shortcuts, not just for matter or hypothetical travelers, but for light itself, reshaping our understanding of how energy and information travel across the cosmos. One of the most mind-bending ideas about wormholes is their potential to allow light, or anything passing through them, to appear to travel faster than the speed of light. From an outside observer's perspective, a beam of light entering one end of a wormhole could seem to emerge from the other end almost instantaneously, even if the 2 points are light years apart. This doesn't mean the light itself breaks the universal speed limit. Rather, the wormhole acts as a cosmic shortcut, bending the rules of space-time in a way that defies conventional understanding. This concept might help explain some puzzling astronomical observations. For instance, certain anomalies in the distribution of light across the universe could be traced back to the influence of wormholes, effectively acting as cosmic bridges that distort our perception of distance and time. It also opens the door to resolving paradoxes, like how certain particles or signals seem to communicate across vast cosmic distances faster than light should allow. Could wormholes be the missing piece in these cosmic puzzles? As we ponder this, it's worth noting that wormholes don't just challenge our understanding of light and speed, they also hint at something even grander: their potential role in the evolution of the cosmos itself. What if these space-time tunnels aren't just curiosities but key players in the universe's story? Let's explore that idea next. Wormholes might be more than just shortcuts across the universe. They could have been active participants in shaping it. Imagine the early cosmos, a chaotic soup of energy and matter, and how wormholes might have acted as cosmic sculptors, influencing the birth of galaxies, stars, and even planets. Some theories suggest that these mysterious structures could have redirected matter and energy, creating the intricate web of filaments and voids we see in the universe today. By acting as conduits, wormholes may have helped distribute material in ways that led to the formation of galactic clusters and the vast cosmic structures we observe. This idea opens up new possibilities for understanding the universe's evolution. If wormholes were present during those critical early moments, they might have played a role in seeding the conditions necessary for life to emerge. Perhaps they even influenced the distribution of dark matter, shaping the gravitational framework that binds galaxies together. While this remains speculative, it's a fascinating thought experiment that bridges the gap between science fiction and cutting-edge cosmology. As we explore the idea of wormholes as cosmic architects, it's worth considering how they might also serve as messengers. Could these structures carry information or signals across vast distances, offering us a unique window into the universe's deepest secrets? Let's dive into that next. What if wormholes could do more than just transport matter or energy? What if they could carry something even more profound: information? This intriguing idea suggests that wormholes might act as cosmic messengers, transmitting data across unimaginable distances. Imagine civilizations separated by billions of light years suddenly finding a way to communicate instantly, defying the limits of space and time. It's a concept that sounds like science fiction, but it's rooted in some of the most cutting-edge theories in physics. One key idea here is quantum entanglement, a phenomenon where particles become linked regardless of distance. Some scientists speculate that wormholes could be the physical manifestation of this entanglement, creating a bridge that allows information to travel seamlessly. Another fascinating angle comes from holography, which proposes that our three-dimensional universe might be a projection of information stored on a two-dimensional surface. If this is true, wormholes could serve as channels for that information to flow, connecting distant points in the cosmos. While these theories remain speculative, they open up mind-bending possibilities for how we understand communication across the universe. But what if this transmission of information goes beyond physical data? What if wormholes could also carry something more abstract, like consciousness itself? That's where things get even more intriguing. What if wormholes could do more than just bridge the vast distances of space and time? What if they could connect minds across the universe, creating a cosmic network of consciousness? This might sound like the plot of a science fiction novel, but some theories in physics and philosophy suggest it's not entirely out of the question. This idea ties into a concept known as panpsychism, which proposes that consciousness is a fundamental feature of the universe, much like gravity or electromagnetism. If consciousness is woven into the fabric of reality, then why couldn't wormholes serve as conduits for this interconnected mind? Imagine a scenario where the universe itself is a living, thinking entity, with wormholes acting as the neural pathways that link its thoughts. This would mean that every star, planet, and galaxy could be part of a grand, universal consciousness, and wormholes might be the way it communicates with itself. It's a fascinating, albeit speculative, idea that blurs the lines between physics, philosophy, and metaphysics. As we've explored these 30 theories about wormholes, we've journeyed from the concrete to the cosmic, from the scientifically plausible to the wildly imaginative. Each theory offers a unique lens through which to view these enigmatic structures, challenging us to think beyond the boundaries of our current understanding. Together, they paint a picture of wormholes not just as shortcuts through space, but as gateways to the deepest mysteries of the universe. As we wrap up this journey through 30 captivating theories about wormholes, it's impossible not to feel a sense of wonder at the sheer scope of possibilities they present. These ideas aren't just science fiction, they're scientific explorations that could fundamentally reshape our understanding of the universe. From the tantalizing concept of time travel to the mind-bending idea of parallel universes, wormholes challenge us to rethink what we know about space, time, and reality itself. They remind us that the cosmos is far stranger and more mysterious than we've ever imagined. What's truly exciting is that these theories aren't just abstract musings. They're grounded in the work of brilliant minds who are pushing the boundaries of physics and cosmology. Whether it's the potential for instantaneous travel across the galaxy or the possibility of peering into other dimensions, wormholes invite us to dream big and question the limits of what's possible. And while we may not have all the answers yet, that's what makes this field so thrilling. It's a frontier of discovery waiting for curious minds to explore. As you reflect on these ideas, we'd love to hear your thoughts. Which theory about wormholes fascinates you the most? Do you think they could one day unlock the secrets of the universe? Share your perspective in the comments below. Your insights might spark an incredible conversation. And if you're as captivated by the mysteries of the cosmos as we are, don't forget to subscribe and join us for more mind-expanding journeys into the wonders of space. The universe is vast and there's so much more to uncover. Let's explore it together.